Okay, cool. So now that the recording has started, welcome everyone to the Karpenter Working Group for May 9th. So I guess getting right into it, starting with some project updates. We released V036.1 sometime last week. And this was a really small release, just on the upstream Karpenter SIG's Karpenter repo. One commit, which included a mitigation for a consolidation race condition that some users have been hitting with do not disrupt pods. And that seems to have been pretty well received so far. So there was a matching release in the AWS provider, but no additional changes other than bumping the version of the upstream library. And then the V1 API, I suppose I should be sharing screen. Okay. So sharing now. Hopefully that's big enough for everyone. So the V1 API and roadmap proposal, that PR has been opened. So definitely if you have any feedback you want to give about this, please make sure to check this out. I don't know if Jonathan or Nick, you have anything more you want to add onto this. But yeah, so I mean, this is our proposal going forward for both the upstream, and we've also have some separate inclusions that are separated out for the AWS provider for V1. So yeah, make sure to check this out if you have a chance and leave any feedback that you may have.
I think there's perhaps some, I'll go and go. I think there's perhaps some details missing that I'm intending to add, like termination grace period isn't added in there. Trying to think, there may have been something else. I think there's still some thinking around some of the East Quest stuff that we need to iron out. But yeah, it's still taking feedback, obviously, and still being updated.
Okay. So yeah, then one last thing before I'll hand it off to Bryce for an Azure update. Very exciting, disruption controls by reason RFC merge. So it's a cool step forward there. Looking forward to seeing the implementation get merged long term.
Yeah, me too, but I'm biased because I wrote it. Yeah, so Azure providers rolling out our V.4 release that adds some support for custom VNets. We had it merged in our provider, but now it's rolling out for the managed platform as well. That includes some other updates for bug fixes like managed identity. There were some problems with pulling from like a managed identity with ACR. You couldn't pull specific images with managed identity. That's being fixed. The full list of change list is in the link I shared if people are interested. Going forward, next, my focus is going to be on the different scenarios for CNI. So, right now we only have CNI overlay with Cilium, but I want to start expanding out to like normal Azure CNI, some other networking scenarios. So that's going to be my focus for the next little while on the Azure provider stuff. I'm not sure if I should put together like a roadmap for that kind of stuff for like our projects that's useful to the community, or just updating when things are done. Need to think about that more. But the biggest thing is that VNet subnet ID change that got in. Also, re-CAPI provider, I did get an issue. Some people are asking about us and CAPI integration. So I figure I'll share that here for our CAPI provider friends. I'll post that in the chat. But yeah, that's it. Just rolling out and releasing to all the regions now. So that's exciting.
All right. Yeah, thanks for the update. Then speaking of cluster API, it sounds like Elmiko, you had an update.
Yeah. First, yeah, thanks, Bryce. That's I'd love to catch up about CAPI stuff if you have like some questions or something. That'd be cool. But yeah, for we've had some design discussions in the cluster API community, and like I think the initial direction we were taking for our proof of concept, we're thinking that it's not going to really satisfy cluster API users as much as we'd like. So we've been kind of reviewing that, and I think we're going to switch from what we were doing to trying to create a more solid connection between like node claims and machine deployments. So we still want cluster API users to kind of encode their knowledge into machine deployments, and then hopefully we can figure out a way to kind of go between node claims and machine deployments, and similarly for the node pools as well. But in support of that, we're having kind of a deep technical discussion. It'll mostly be about cluster API topics. But interesting if you're into it from the provider side. So that's going to happen next Thursday on the 16th. I've got a Google Calendar invite. Unfortunately, because of Red Hat's security policies, I can't share the public invite. So if you ping me on Slack, happy to add you there. And there's a thread linked here where we have a document. We've been talking about some of this stuff as well. Garvin, I see you had your hand up. Did you have a question?
Oh, yeah. I was going to ask about the thread and specifically around the backend resource for no claims, but I'll take a look at the thread.
Cool. Yeah, a lot of what we're going to talk about is in this document that I put together. It's linked in the thread. But these are kind of questions that we're running into as I'm implementing the PR, as I'm implementing the POC. There are questions coming up about like how do we use how do we expose things like pricing details in the cluster API environment? And that's something that the cluster API community hasn't really tackled in the past. So, yeah, it'll be an interesting question for us. And I think there are other things along that line, like how will we answer getting up-to-date information about offerings and those kind of things. So I think a lot of the discussion will be around like those kind of details. But anyways, that's kind of where we're at. Just wanted to let folks know.
Yeah, thank you. So looks like we're pretty quiet on community questions. Looking to move on. I don't know if anyone has anything impromptu or if anyone has anything they would like to add into the doc.
Sorry, I was going to add something,
Yeah.
but I did not. It's partially an RFC, but I think it's around the ODCR design. I don't think we have fully a concrete design for the RFC right now. But would love to get some feedback for users on AWS with Karpenter around ODCR and how they use it. I think right now we're looking at a few things. First, I think for capacitor reservations, we want to see how flexible or do we need to be in Karpenter, and what kind of use case do you guys do most users use? Like at least for my own use case, we usually allocate ODCR, a capacitor reservation, and then we'll put in a capacitor resource reservation group, which allows us to pick up ODCR instances across availability zones. But it has a weird behavior when you use it with Karpenter because Create Fleet will fall back into on-demand nodes when you use a resource group. Like, is that a concern for users? Like, would you want your ODCRs to always be contained within the ODCR? If you attach that to a EC2 node class, for example, like how users looking at how they want to use ODCR. Like, it'll be great if anyone can comment on the ODCR RFC, and if you have any like comments on how you use it here, we'd love to hear the feedback here too.
Okay.
Fallback is also kind of interesting from a capacity modeling perspective. I think one of the ideas that was kind of kicked around was, you would represent the availability of the capacity reservation as an integer value, and therefore the available field that currently sits inside of the cloud provider API today that is currently a Boolean becomes integer, and you can represent like unlimited capacity. I mean, that's effectively in the general case, and then in the capacity reservation case, it's constrained. I think if you fall back, you then represent like, that's now viewed as like a different offering type for those that are familiar with like the quad router interface. Like you basically have an instance type and has two different offerings. One has a price that is the non-capacity reservation price. And then you have another that is a capacity reservation that has a limited availability and has a price of effectively zero because you've already prepaid for it. I think potentially there's also some, so yeah, I think the use case is important, like understanding if, like, does the fallback behavior need to happen within a single node pool? Because users don't care about, like they want the fallback behavior generally. And we like want to reduce the number of node pool configurations that somebody has to set up, because if you want the fallback behavior in the general case, you can achieve it without having fallback behavior directly in the API. You just create two node pools with different weights, and one is pointing at a capacity reservation and one isn't. But now you potentially, like, I think the big thing that we're going to have to fight with here is like, how much does this explode the number of node pools that you have to specify? Because you need a different node pool. Like if you do it a per capacity reservation, you now need a different node pool per capacity reservation, and you have like a bunch of different capacity reservations in different AZs. You probably want to think about those as a logical unit. And do you want to create, like, have to be forced to create different node pools for each of those different capacity reservations? And then Karpenter also has to do, like, it treats like node pools without weights in isolation and kind of picks them effectively randomly when scheduling. So it gets kind of kooky with like you like, and it does it consistently. I guess, does it do it randomly? It may do it based on name. So there is a consistent ordering.
Yeah,
So
consistent,
it gets
but it's not something you should necessarily rely on because it is semi-random.
Yeah, there's no
It's an
contract built
implementation
around it, but
detail.
it is, yeah, there's no contract built around it, but it is done consistently. So you may get some kooky state where we prioritize an AZ. If you have a bunch of different capacity reservations with the same weight. So I don't know. There's some like scheduling overlap that we need to think about here as well. If we do like a per capacity reservation per node pool. But yeah, I think there's a bunch of interesting questions here. I also owe y'all a review. I've been busy, but this is something I know you and I think Thorben has also been looking at it as well. So
I also have to update it. I had no time to go back to looking at it, so Thorben has been doing most of the testing out work, and I'm like, okay, I need to rewrite or add to the ODC, I mean the RFC, but I have not.
Okay, so I guess, does anyone else have anything they would like to raise?
Oh yeah, that's a good question, Jeremy. I was wondering this as well. Is there any customers operating at like 2,000, 5,000 node scale?
Are you asking because you're doing it, or are you asking because, like, Jeremy, are you asking because you're doing it, or you're asking because you're interested in trying it?
We're interested in trying it. We'll probably be not doing a scale test immediately, but within the next couple months, probably doing a scale test. I was just wondering if anyone else has already done this.
So I think we're aware of people that are running at the scale. I think we need a better understanding, like as a maintainer team, of how performance looks at this scale. We've heard success from users around being able to do this. I think that we're a little skeptical about some scheduling performance, depending on how complex like your pod, like how many pods are mapping to that number of nodes. Because in reality, like the number of nodes, I think affects the memory footprint and to some degree affects the scheduling performance, but it's the number of nodes, effectively like times the number of pods in a lot of ways. And it also depends on the complexity of the scheduling requirements on those pods. I think Nick, this is probably why he came on camera. He's probably a comment on like some of the work he's doing on getting like a better feeling of like benchmarking around these kinds of things.
Yeah, I'd say that just like the classic, like, scalability has so many different dimensions and things can break in a lot of different ways that like some people have different performances at smaller nodes, but with like huge amounts of CRDs or something like that. I think crossplane creates a lot of CRDs. So if some people have like a lot of CRDs when they're using that. The big thing for how we can understand scale, like Jonathan was talking about, is that we're working on running some of this like scale testing, specifically in the upstream provider, sorry, in the upstream repo, not in any of the cloud providers, so that we can get a better understanding of how the Karpenter algorithms work at scale. So that'll be running on like kind clusters, which is just like a fake cluster, or like a bare bones cluster. And then there's a Quark, which also runs just nodes without a kubelet. So this allows us to basically test all the performance and profiling based trade-offs that we make with our PRs to get an understanding of like if we're doing something that's right without having any sort of like cloud provider details included in it. I think the way that this might be useful for you is that in the future, if one of the goals is to have this performance and profiling data published on PRs after like the tests run. And hopefully, as we get that, more fleshed out and we have more data there, you'll be able to see things like, like 2000 nodes in this scale up, how long did it take? And then you might be able to use that to kind of use that as a baseline for like, what's the like best performance you should see, because that's like obviously like the most stripped away cluster without any like cloud provider details.
Yeah, it'd be nice to see that. Yeah, especially on unit tests, so we don't have, or on PRs, so we don't have regressions. That'd be nice.
Yeah, I don't, it's been a while since I looked at the Karpenter code, but we run clusters that are over the size of 5,000 quite consistently, but it's not managed by Karpenter. It lives in the mixed world of like Karpenter managed and not Karpenter managed nodes. But from what I can tell, like Karpenter still considers a majority of the pods and nodes that are not Karpenter managed during its evaluation. For us, scheduling seems all right, but the consolidation is really bad. Like it takes Karpenter upwards of 4 or 5 minutes to perform the consolidation calculation, and I was like, okay, this is a little slow. But I think that's the only hiccups we've seen so far. But yeah, like because it's not fully managed by Karpenter, like it's likely skipping some paths. But then I think a lot of the consolidation and scheduling logic does consider a majority of the things because we never labeled it to say, I forgot what the label was, the Karpenter, like to ignore it. So I think it's considered within its own calculation.
Yeah, during disruption, Karpenter needs to understand, like when we disrupt a node, where will these pods schedule to? So if it can schedule to those other non-Karpenter provision nodes, we do have to simulate that to see if we need to create a new replacement node claim.
Right. Even though, yeah, it does that. So it needs to consider a world, even though it doesn't match the world. Yeah. So in a way, it's like a good, I guess, test of like what Karpenter looks like in a relatively large cluster, but then it's not that doing all the work around that.
Yeah, there's also like we're continually trying to improve the disruption performance there. I have a giant PR out right now for Consolidate After, if you've seen that. And the hope is that that will be able to theoretically reduce or like, asynchronously get us to detect consolidation and execute consolidation in like different threads. So I think that's probably something that's going to be pretty helpful. I know that there's maybe also the work that we can do of like allowing people to say ignore these nodes. But I think that's just going to have to be another like feature request, because there's a lot of, like what Jason was saying, there's a lot of considerations with like being able to understand the full schedulability of a node.
Is it possible that you link the Consolidate After PR that you're working on, or so we can take a look? There was a few issues that was cut for like I think consolidation performance and stuff like that. That I had some like comments on that. I think low hanging fruits, but I'd like to see.
Yeah, the hope is that like the previous testing I was talking about can be used on this as like a first thing that like as proof that like we can get profiling and scale testing data to like validate if we're making the right decisions here. So I'm hoping that this can tackle a lot of other like a lot of other like details in terms of like scale performance, but yeah, we'll just have to see the scale testing data, and my theory is that it should improve it.
It will also be good to see. Oh, sorry, just a quick comment. It will be good to see like what is the resource you're giving Karpenter when you perform the benchmark. Just because I'm guessing it varies quite a bit depending on like CPU memory that you're giving Karpenter. Like I'm guessing the chart shows whatever default is, but it'll be if that's the default and if that's the resource level that you're benchmarking against, and it should call it out or something. Yeah.
Yeah, I think that's the hardest part about getting scale tests is that people have different control plane sizes, they have different resources they give Carpenter, they have different limitations they put on their like each of their components, and they have also like different daemon sets that slow things down. So I think that like the gist of it is that like if you want to get a gist of how performant something is, the best way is to kind of test it yourself. Because your environment might be very different than someone else's environment.
Okay, so I have one question. So we have basically did this Carpenter installation. So the first thing is we are using it on a large scale for a couple of clusters, but the problem that we are seeing is the scaling up of the instances. Basically, the Carpenter is only leveraging the small node group types that based on the memory and the CPU that we are providing, and we are mostly leveraging on-demand instances. And but we see the cost of the cluster was going down if we can able to get like instance higher than the lower ones, maybe like without leveraging 2 or 3 instances of lower ones. Rather than that, if we can able to leverage the higher end machines, that is reducing the cost, the overall cost, like the backend EBS volumes and all these things. I don't know if this kind of feature was available from the Carpenter level, but yeah, that's one more question I have.
So do you have multiple node pools with these different like instance sizes, or would you expect that within a same node pool, Carpenter could choose larger instance types and bring your costs down?
We have multiple node pools, but basically we are either using like AMD or Graviton. That's for the multiple node pools, but not for the instance sizing.
Okay.
So
I'm not sure have you seen some of the previous like this. I feel like this has been brought up before. I think there was some conversation around like topology constraints and how Carpenter deal with that. I don't know if you have any of those in your cluster, which force Carpenter to spread, even though it is a preferred topology constraint, it will spread nodes and it won't consolidate nodes, which cause your cluster to be possibly smaller or like it's more nodes and smaller instance types than you think it should be, simply because it attempts to be more safe. I don't know. Have you seen that doc or FAQ somewhere in the Carpenter docs?
yeah, we have seen, but
I guess, do you have option like preferred topology constraints in your cluster? If there is, then that would force more nodes to exist at a smaller instance type, likely.
okay. Yeah, that's all I have. Thank you.
Yeah, I
So
mean,
just to be clear,
definitely.
sorry, I think I missed the piece. This is the case where you're not seeing us pick a single node, you're seeing us pick multiple nodes that are all small. Is that right?
Right, basically picking only the small nodes. Yep.
Okay. Yeah, it's interesting because yeah, I think Matt and Garvin are probably correct. There's probably additional constraints that are going to drive
Mhm.
multiple nodes because we see requests, but they typically go in the other direction. Like because Karpenter is a heuristic that tries to pack as many pods onto as large of nodes as possible because it's difficult to figure out what the optimization is there. Like generally what we hear more than anything else is, oh, you're like, you shouldn't have overpacked all these pods on one big node. You should actually split these pods into multiple nodes because that would be cheaper. But it's kind of like, it's a rabbit hole and like it maybe eventually something we would think about doing, but it starts to get very expensive to figure out all the combinatorics of all the options that you can have. So you have to pick something. But yeah, generally if you're seeing a bunch of small nodes rather than one big one, it sounds like additional constraints.
So, do you mean to say like you need to add additional configuration to that?
No, I think people are saying that you probably have additional configuration that is causing Karpenter to spread, because what would happen generally is that either Karpenter picks a bunch of small nodes and then like, because you have trickle on your pods, so some pods come in and schedule to a small node and then more pods come in and schedule another small node, et cetera. If the combination of those small nodes into one big node would save you cost, Karpenter would eventually consolidate you onto that one large node. So you should eventually, even if your initial state has you as like very spread out, you should eventually descend to like the best behavior in terms of like saving cost with a smaller number of nodes. But if you, I guess the two cases are either like you have constraints on your pods that are either preferred or required, because Karpenter treats preferred constraints as required, that necessarily cause Karpenter to think it should spread your node or your pods across a bunch of different nodes, or the larger nodes options that would result from those pods being combined aren't actually cheaper than the sum total of them individually.
Yeah, so like if you have like, node name, like node name domain spread, it'll keep one node of each for each pod out there. Or like you have availability zone spread, it'll keep like 3 nodes for your pods. And then what have we seen also is like if your cluster has a lot of churn, like you bring up a lot of pods and you bring down a lot of pods and you bring up a lot of pods and bring down a lot of pods, like it doesn't consolidate to a bigger node size because like there's a bias to, at least from what we can tell, like bias to small instance types because at least in the short term, because when there's a lot of pods that come in, because it batches pods that are coming in and then schedule a node for those pods, usually that batch is smaller than however big or however many things are running in cluster. So it doesn't actually, also it will have a bias to bringing in smaller instances. And then you have to wait into consolidation for the big nodes to come in. But if there's a lot of churn in your cluster, Karpenter tends to not be able to consolidate. That's because there's so much churn going on. It doesn't know what's the right size. And like Jonathan said, you can mess around with the batch interval and batch timing or period. I forgot. And you might be able to get like a bigger node as you wait for longer, but it takes some like testing to get that number right.
Yeah, it's been like maybe we have started this maybe like a couple of months since we're turning to like large scale now. So yeah, that's where like I mean it's always trying to keep smaller nodes. So then we are using the greater than maybe 4 CPUs or something like that. Then we avoid few things, but yeah, at the same time we are expecting like to have like maybe M5 4x large but it's going with M5 2x large. So but we don't have, as you said, like we don't have any preferred or required constraints in the pod in the deployments. It's like a just plain deployment manifest, but still like it's being trying to keep initially when we turn from the auto scaling group to Karpenter, yeah, it's giving a very big size of the nodes, and like at later point, it's scaling down to the minimum instance types, the smaller instance types.
I have nothing to add because I've seen some of the behavior.
Sure.
It's really hard to explain, but I guess one thing that I want to echo was that it is very hard for the users to understand why Carpenter has chosen to do something or take the shape of something for the cluster, because it's like a black box for consolidation. It's a black box of why it chose something or didn't choose something, and it doesn't tell you why.
Okay.
And it will be, I'm just saying, like, it will be good as a feedback to say, oh, somehow being able to expose that kind of information in some way. I don't fully understand how we can expose this. Like, it'll be nice to understand the calculation that Carpenter have made and why it did something, because you're like, oh, why is it this way? And I don't know. It just happens to be that way.
Yes.
So I think to add a little bit to that, I 100% agree. Consolidation in particular, I think just like the scheduling decision. Well, scheduling decision making is a little bit of a black box, although the output of that black box is the node claim object. So that does give you a little bit of insight, at least into doesn't, I guess, not specific pods, but it at least tells you what is being passed through. If you're using AWS, what's passed through to the fleet request, because fleet is also a black box. So it's like you get some intermediate detail on like what's sent over there, but on demand, I guess it's a little simpler because it's whatever's cheapest, and so that's kind of an easy thing to reason about if you know what options were being passed through. But once you get into spot territory, it's kind of like that also becomes a black box. So that's probably not something that we can necessarily solve, just because that's by nature of the API. That's how it works. So at least you get some detail in the middle there about like, okay, Carpenter made a scheduling decision. It launched a node claim. That node claim has a certain set of pod requests attached to it, and it has a certain set of requirements attached to it. So I can see that, but 100% agree. Like once the decision that Carpenter makes is not a decision, like once that's kind of, I guess, not the right way to word it, but like with consolidation all the time, you've got, I think the most, I guess, obscured thing is when Carpenter doesn't make a decision on something, which there's no way for us to like hydrate data into a custom resource object because we didn't do anything. But the reason why we didn't make a decision is not clear. And we try and surface that through events as best we can. But I 100% agree that it's still not the best experience. And Nick and I have done a little bit of thinking on this, and we're still trying to do some thinking on it. But it'd be great if, like, Garvin, to your point, like, I don't know if you had any thoughts on it, or like getting more feedback from people that I'm sure are also frustrated with this kind of thing, where it's very difficult to reason about what's going on. Like we want to improve this experience because we hear this a lot. Yeah, trace logs are interesting. The thing we battle with is like how much log spam do we produce? Like, for instance, because we were running a ton of scheduling simulations. Those of you that are familiar with maybe older versions of Carpenter, like you probably have seen, if you're using preferences, you'll see like I think prior to maybe 36 or 35, you'll see like relaxing soft pod constraints when it's doing scheduling simulations, and those just like spam your logging. So we're battling with like, how do we make Bryce is unhappy. It's we have to battle with like, okay, how do we make it visible and readable and parsable, and like I'll put all the information there so it can be like used, but also not make it so overwhelming. And maybe the solution is like protobuf output that is stored elsewhere, that stores like historical information on what has been done, and then that can be parsed by some other tool. That's just one idea, but
I guess in my mind, it doesn't even have to be as thorough or like detailed. If like every 5 minutes you tell me we tried to run consolidation, we didn't find anything that would have been cheaper. And here's like the CPU memory and like approximate spread or whatever that might be. And like we couldn't find anything. So we moved on. Like that could be enough of a starting point to understand a little bit more. And maybe from there, it can be like, okay, maybe I need more information as to what the spread looks like or whatever that might be, and can start like going deeper in detail and add that feature as we go. It's just right now, we don't even know what we should be thinking about or looking at because there's no detail in terms of like figuring out how like, oh, it did some scheduling, it didn't find anything, but like why? Like, I don't even know where to start, but maybe that's okay starting point. Like every minute, it's like, hey, we did this. Here's like all the resources it is per node pool, whatever. And here's all the nodes, and we didn't find anything cheaper. Moving on now, kind of thing.
I guess to that point, like, do you find the eventing that exists on the node claims and nodes useful? Because I think there is some of that on those.
Yeah, I think it's helpful to see why a node wasn't consolidated, but I think it's too granular to make any understanding like at a broader scale as to what is actually happening. Because okay, this particular node was not consolidated, but I'm more interested in like a higher level, like or maybe across a whole node pool, why nothing happened in this node pool. And it's hard to like add up all the node claims and trying to figure out like what actually happened, if that makes sense.
Yeah, that's also complicated as well. I mean, this whole thing is
Yeah.
complicated.
Yeah.
I think that's clear. Because like we also do scheduling simulations across node pool boundaries, and depending on how your cluster is configured, the node pool may be a hard boundary, and consolidations could really realistically only occur within the context of a node pool because you've isolated them, but they may also not be. So it starts to look very. Yeah,
Yes.
I agree. We should take an iterative approach here. I think we need to do more thinking on it. I think use cases and like I mean, not use cases, but like understanding where the gaps are is kind of that's the big thing. Like once we understand where the gaps are, we can figure out how to fill in. So yeah, it'd be interesting to talk about this maybe in the Karpenter dev chat or
Sure. Yeah.
like start keeping like writing things down that we think are gaps in our observability around this thing. Alex is coming. Yeah, can we just say we use an LLM to schedule your pods? Then does that make everyone happy?
It's AI.
That's
could
right,
probably
it's AI. You don't need to know how it works.
KubeCon would welcome us on the stage to talk about our LLM for pod scheduling and see.
If you're done with it, I have a couple of questions around Karpenter. Yeah. So I'm trying to figure out the upgrade use case. Like when I say upgrade, it's for the node upgrades, the node disruption scenarios. So I'm from Intuit. So the way we do the upgrades currently is we have this end-to-end control over when upgrade triggers, when the cluster upgrades are triggered, and when the upgrades complete. Right. So in order to maintain the same parity with while we're trying to migrate to Karpenter, I'm trying to understand if we can have like better information surface. So starting with, let's say in a node pool, like do we already know the information that how many nodes are there within a node pool? Is it being tracked or maintained in any of the CR? That's one. And also with respect to some visibility over the disruptions as well. I know within the node claim, we can see that how many number of nodes, if a node claim is being disrupted or not, we can see that. But apart from that, like any other drift information or the disruption information is being surfaced in any other CR. Like, do any of you know it? Have you tried this out?
Yeah, so I mean, each node pool, so if it's drifted, expired, etc., or each node claim is going to have the drifted or expired status condition on it. Additionally, there are some metrics that we do publish around disruption that could definitely be worth checking out. As far as, I don't actually know off the top of my head if number of like, were you asking like if the number of total nodes?
Yeah, total nodes in the node pool, on a node pool, yeah, on a node pool.
Not actually certain off the top of my head if that's
I think-
committed.
Number of nodes on the node pool should be in the status. I
Is
might-
it?
It is not there today.
I
Remember-
think total CPUs is, I don't think total.
Yeah.
Yeah, I
nodes
did find
is.
total nodes anyway.
Yeah, I mean, you could probably aggregate it from like how many nodes have that node pool label. But as far as like a single place, I don't think there's anywhere today.
Okay, so currently we don't have anything to track the total number of nodes within the node pool. And can I create a ticket for that and see that if it gets sufficient traction and if others also upvote that and probably work on that? Is that fine?
Yeah, I
Or
think.
do you guys think that's not?
Correct me if I'm wrong, was that part of the V1 API suggestion? Thought I may have remembered that being there.
If it's not there, I can add it. It's like a pretty, it's a pretty straightforward thing. I think the original concern around doing that kind of thing was, yeah, it is there actually. I think the original concern around doing that kind of thing is that people might reason that they can also set limits on it, which is like a completely separate question. In my mind, it seems completely reasonable
Yeah.
that you would want to know the number of nodes
Within the
that
node
are
pool.
provisioned by a node pool. And you can decouple that from the need to set limits on it. Because once we talk about node limits, it's a very hairy topic. It is definitely a separate conversation, I think.
Yeah, I mean, today there is any node created by Karpenter is going to have the Karpenter SH node pool label. So you could aggregate across nodes, count how many nodes have the label for that given node pool. And then, yeah, it does sound like this is something that's already being tracked for V1.
Right, like we can definitely do that, but I was just hoping that if the information is already available, we can just leverage that. If there is no plan to publish that number of nodes, then probably I'll be doing the same. And also additionally, the drift is identified differently for the nodes, right? Like, for example, you guys don't consider the changes in the requirements as a drift. So, however, with our current approach for the upgrades, we actually consider like an instance type change as an upgrade. So it's a little, I'm just trying to understand how we can track that here better. Looking at the node claim is one option. Sorry.
Sorry to interrupt you. We do take into account the requirements for drift. Are you seeing that not happen?
Oh, no, the drift happens. It's just that the hash doesn't get changed because of which, yeah, there is no clear way to track the upgrade progress, like how many nodes are there and how many nodes are rotated. So the way we currently do the cluster upgrades are when the node upgrade and the node rotation starts and completes. So that's when the entire upgrade workflow is marked as completed. Versus here, Karpenter is probably pretty well suited for the background upgrades, which is just happening in the background and we don't really look into it. But as a fintech, it's a requirement for us to rotate the nodes more frequently. So that's why I wanted a better control over the upgrade. And that's why this question.
Yeah, so I think the status condition has, if you look at the node claim status conditions, that should give you a number of things that are marked as drifted. So that's the best mechanism that we have today. So like the hash isn't maybe a great example only because there are two different mechanisms for updating, like Karpenter considering things as drifted, because you can imagine there for things like subnets and security groups, there's a section on this in the Karpenter docs as well. But for things like subnets and security groups where they're discovered inside of AWS, if you're using these two node class, those things can also like be changed out of band of Karpenter's configuration actually changing. So given that there's this concept of like discovered drift, I guess is how we're labeling it, which are things that are not configuration changes. They may or may not be configuration changes, but they're treated as like, does the superset of options you provided contain the option that is assigned to that instance right now? So is the subnet that this instance exists in, is it within the superset of options you've specified? Same thing with instance types. It's like, is the instance type that this is running with this instance, is it in the superset of options that you specified in your requirement set? So those things don't necessarily affect, they're actually specifically excluded from the drift hash calculation. And the reason being, like, obviously, if you were to change them, it would always update the hash, and then the whole point
Trigger
of
all the
checking it is
nodes.
completely pointless, right? Exactly. So,
Yeah.
so the hash is only useful for, well, it's useful for almost everything except for those specific edge cases, like those specific things that are called out as not being used for that kind of mechanism. Which I can point you to, give me a second, but that's why I'm saying, like, the way that Karpenter actually, like, even signals that it, like, it should rotate nodes is on the drift status condition on the node claim. So if you wanted to check, like, it's the same mechanism that Karpenter's using to actually orchestrate it, you can check that status condition to see how many nodes it thinks are driftable. Now, are there metrics on it today? The answer is no. There are metrics on that Jason pointed to around the number of eligible nodes, which is a slightly different calculation from the number of drifted nodes. Eligible has to do with, like, there's additional eligibility criteria that Karpenter considers when it's considering something for disruption, including whether PDBs allow the node to be disrupted and whether there are pods in the node that could block it from disrupting things. That potentially is a useful metric for you to watch, because it also determines eligible nodes by reason. So, like, drift would be a separate label in that particular case. I was actually, yeah, does that answer your question?
Yeah, like somewhat. Thanks a lot for these metrics. I didn't know those metrics existed. I can take a look at that. Also, so you mentioned there's some drift documentation. Is the one that you shared in the chat? The node
Yeah,
pool disruption
yeah,
concepts.
that is the right
Yeah,
pointer.
I didn't go through this.
That's,
Okay.
yeah, I actually may have, I mean, that is the right section, but I think the top level section is that. I'm talking about the special cases section.
Yeah, it looks like this has the exact example of instance types changing
Right.
and why that wouldn't affect the hash.
It actually leads me into a question that I'm curious about from anyone here, which is, does anyone do custom cube state metric scraping for Karpenter custom resources? Like, that silence is a no. Oh, you can signal no. What? That's crazy. I didn't know you could do that in Zoom.
Garvin's an advanced Zoom user, what the heck?
Yeah, clearly.
You
Yeah,
can
y'all,
react to it.
I don't know if any, well, you guys know we used to be on Amazon Chime, so we've upgraded our experience. I shouldn't say that, but
Yeah, careful, these are recorded, sir.
that's right. I was just curious because, like, I know that there are open source components, like Flux is a good example that directly they like ship, or I guess they vend out within their repo like a plugin mechanism on top of KubeState that allows them to, like, surface all their, like, you can basically define metrics that KubeState will scrape based on spec and status fields just by writing a config. So there's, like, this question of, like, whether Karpenter should directly support these metrics or whether it should just vend out the config for you to use KubeState. It's kind of a little bit is like a trade-off question for us as well, because we have to maintain the metrics if we vend them ourselves. But anyways.
I think it's slightly better to fend it yourself, but that's like a very soft, you should do it yourself, just because we are quite behind in the KubeState metric version upgrades, and then we don't always rely on KubeState metrics. Like, okay, I guess at a high level, like, we dictate what is being scraped from each kind of metrics just to keep our, like, MTS reasonable, so we don't blow up anything. We don't do a lot of KubeState metrics is because it has a lot of metrics, and if it's like an unbounded, unknown amount, like, oh, start finding Karpenter and stuff and whatever, it's hard for us to know ahead of time bounded. Whereas if it's staying within the Karpenter world, then when we scrape, we can be like, hey, this is Karpenter, drop these ones. Because we don't need it, if that makes sense.
Yeah, that's the biggest problem with KubeState metrics, is it's just too many metrics, and, like, the way sample limits work in Prometheus, it's, like, kind of hard to control what you drop and or even load in. So, like, if you have sample limits to prevent even scraping certain endpoints after a certain amount, like yeah, it's kind of hard. But also Carpenter
Yeah.
managing a low cardinality series means that like people can be more confident in scraping Carpenter itself. So just being mindful of that, you know.
Yeah, I think it's a bit of an unfair question because it's saying, would you like to install a different component or not? And like everyone's going to answer not. So, but you know, there's obviously a trade-off toward maintenance burden. I don't think it's like that high of a maintenance burden. I was just curious because it's a little bit like the cert controller case for anyone that's familiar with like trying to build a controller with admission or validating webhooks. It's like, hey, like control runtime was like, yeah, we don't want to manage the certificate flow, so we're just gonna like vend it out to this other thing, but no one wants to install the cert manager or like force users to have to install cert manager as a separate component. So it's it's not a great experience. So it's kind of it's also a question, I guess, on kube state ubiquity because it's like if everyone has it installed, then it's like not that much of a lift to add config, but based on this, I'm not convinced that everyone wants, or maybe everyone has it installed to some degree, but not everyone wants to have it installed. So
We have in some very limited things just because, yeah, we can't blow up MTS from scraping it.
One more question. I have seen some of the times where a new node claim is being created for the pending pods that there is a node claim that gets associated with the wrong node pool, but then eventually it kind of goes away and it's fine. Like it just is with the correct node pool. So is that expected or is that a bug? Or have you guys seen this before?
What do you mean the wrong node pool? Like the label on the node claim says it belongs to like what exactly?
Right. Like so, I have like basically two kind of node pools in my cluster. One is for AMD instances, the other one for ARM. And when I provision a node pod for a particular node pool, like for let's say for AMD, I see the node claim associated with the ARM gets created, and then eventually it kind of goes down. Maybe the label itself. I don't know if it was actually for the ARM instance indeed.
Yeah, it sounds like if the architecture is just not being respected, it sounds like that's a bug, but I want you to open up an issue so that we can,
Sure.
like if your steps reproduce it in the issue, that'd be great.
Yeah, I did see it like pretty consistently. It could be just a label issue,
Yeah,
but the node.
like that, but I think that probably best through an issue.
Yeah,
I'll create an issue.
the same thing.
Did someone say that they also saw the same thing?
Yeah, yes.
Oh, okay.
Okay, looks like we have a couple of minutes left till we're at time. Anyone have anything, any final thoughts they'd like to share? Or do we want to go ahead and end it for today? All right. Well, thank you everyone for coming.
see it.
Goodbye.